In this video, we're going to talk about different time series patterns, and we're going to use data file pattern. So first, let's take a look at the definition of time series. So when we have a sequence of observations on a variable of interest, let's say sales or demand, for example, that are measured at successive points in time, which means that we actually record historical values of sales or demand or whatever variable of interest that we're looking at for a period of time, but we just record it periodically, right? When we have that, when we have the date or time and also the value of that specific variable, this is called a time series data set, right? And each time series may show a different behavior, different pattern of change of the values, right? And in order to be able to use the right time series forecasting method, we need to be able to identify the pattern that exists in that specific time series that we're studying, all right? So now we're going to talk about different types of pattern that may exist in time series. So I'm going to open data file pattern here. So in this data file, we have a few sheets here. Each sheet contains data that shows a specific type of pattern. And we're going to talk about different patterns one by one. So I'm going to start off with the horizontal sheet here. This example actually contains the sales, the weekly sale of gasoline, which by definition, gasoline is a stable, is a product with a stable demand. And this is what we expect. Let's see if this follows a horizontal pattern. And we're gonna actually go over the definition of horizontal, but just bear with me. So in order to be able to visualize the time series and hopefully identify the pattern that exists, we use time series plot, or simply the line chart that we all know how to do it, right? So I'm just gonna select the variable of interest. So we're gonna do a line chart, insert, and a line with marker. I'm gonna go with line with marker. That's the tool that we use in this chapter for identifying, for first visualizing and then identifying the pattern. All right, let me just clean it a little bit and add access title, sales, thousands of gallons, and then week. When we want to identify the pattern, usually the first step, the first thing that we need to do is to add a trend line and see if there is any trend, all right? So I'm gonna just do this. If I add a trend line, I see that it's, I'm not gonna add the equation or anything, but I mean, if I just visualize it with just my, basically my bare eyes, if I just look at it, I can see that there is a, like there is no trend, right? So we don't see a gradual increase or decrease in the data. And then, but the data is fluctuating around the mean. So if this is constant, if the trend, there is no trend, it's actually, there is a horizontal line that summarizes this data set. So the data points are actually fluctuating around a constant mean, which is more or less, which is very close to 20 here. So when we have random fluctuations around constant mean, around a flat line, that's when we call the pattern horizontal. So we just need to make sure that there is no trend. And so that's the first thing. The second thing that we need to check is to make sure that the fluctuations are random. Sometimes the we have a like a flat line, but the fluctuations are not random. In those cases, we may have seasonal pattern, not horizontal. So when we have random fluctuations around a constant mean, I'll talk about seasonal in a minute, but horizontal, when we have random fluctuations around constant mean. And when we have horizontal patterns, I mean, we are going to use different techniques that are different from when we have a trend or seasonal and trend together. So this is basically how we identify it. We just visualize it, look for trend. If there's no any trend, our first guess is horizontal. Then we just need to make sure that fluctuations are random. They're not repeating themselves. So if that is the case, then we can call it a horizontal pattern. All right. This is something, it's good to know. It's on this slide, it's in the book. When we have a horizontal pattern, a data set with a constant mean and constant variance over the time horizon, if that is the case, the data set is called a stationary data set. Which means that the mean and variance are constant over the time horizon. Sometimes you may see, let's say, if you just look at the cursor here, sometimes you see the mean is constant. It's around a constant mean, but the variance at some point increases and then decrease and then increase. So the variance is not constant. It varies with the time. So in those cases, those are not stationary time series. So that's just for your information. You don't really need to worry about it. For us, as long as we see a graph like this, random fluctuations around the constant mean, that would be a horizontal. Next one, I'm just gonna draw the line chart. And if I just again, so this is annual sales information. All right. Now, if I add the trend line again, the linear trend line, this time I see that there is a positive slope. So there is a significant slope. Slope is not zero anymore. All right. Which tells us that there is an increasing trend. So we expect the sales to increase from a year to another year, from a year to the next year, to increase by 1.1. All right, so that there is a positive slope. So the sales is positive. So this would be a case of trend, a consistent, a long-term, gradual movement in either upward or downward. So this is what we call a trend pattern. So gradual, usually long-term shift in data, either upward, either increasing or decreasing. So trends can be, trend patterns can be increasing or decreasing. They can be linear or non-linear. So they don't have to always be linear. I mean, let's say this is now a non-linear. We don't have a lot of data points, but if you have enough evidence to support the non-linearity, then you can claim that you have a non-linear pattern, right? So for example, this one, if I have the equation, you see now it's a non-linear, it's a logarithmic trend line, but so it can be linear or non-linear, the trend. It can be increasing or decreasing. The key here is the gradual movement, the gradual shift in data. And so if we have some data, some like data that are that show horizontal pattern, and then suddenly stays go up and then horizontal pattern again, that wouldn't be called, that wouldn't really be called trend. So if you have sudden change in data that, or short-term change in the data, that won't be called trend, right? So you can't really associate it to long-term consistent shift in the data. So as long as you see the graduality in increase, or I mean in the movement, whatever direction that is going, you can call it a trend. Next one, seasonal. So here we have quarterly information, sales information for umbrellas. So if I just plot again the line chart, I see that, let me just, so these are quarters. All right, or period numbers. Okay, like I said, always the first step when you want to identify the pattern would be to add the trend line. So if you add the trend line here, again, the slope is almost zero. It's almost a horizontal line, but the fluctuations are not completely random. The fluctuations are repeating themselves. I mean, if you just take a look, so we have this is quarterly sales information. So every 4 data points would belong to 1 year, right? So year 1, year 2, year 3, year 4, and year 5. If you look at the data a little more carefully, you'll see that always the pattern is like this: up, down, down. So that's for year 1. Year 2, up, down, down. Year 3, up, a little bit up, down, down, up, down, down, up, down, down. So the same pattern is repeating from a cycle to another cycle. All right. So now we have a cycle. Cycle would be the length of the time that a complete pattern happens, takes place actually. And then, so that would be cycle 1. And then the similar pattern happens in the next cycle, in the next cycle. So here the cycle is 1 year, and then the seasons here are quarters. So each data point, each actually instance of recording would be here in this case would be a season. So seasons in seasonal definition, in our definition of seasonal pattern, do not have to be year season. I mean, if your cycle is 1 month, your season can be weeks, can be days, all right? If your cycle is 1 day, then seasons can be different shifts of the day. They can be different hours or different few hours, right? So this you just need to understand that seasons that we're talking here about would be a subset of the cycle. And cycle can be a year, can be, so here cycle is usually less than a year. When we're talking about seasonal, our cycle is less than a year. So a year, or let's say half a year, or a quarter, or a week, a month, a day, or an hour. So they all can be a whole cycle, and a subset of a cycle that shows at least you should have 2 seasons, all right, for a cycle. So this is how we define it. And the definition of seasonal pattern, when you have recurring pattern or repeating pattern that actually repeats itself in every cycle. And then cycles should be less than recurring pattern. Cycles usually are less than or equal to 1 year, and there is no trend. All right, so this is how we define seasonal. Next would be, we can have actually a combination of horizontal and seasonal. Is seasonal itself when you have numbers fluctuating around a constant mean, but they're not completely random, so that would be seasonal. Horizontal and trend cannot be together, so you either have trend or no trend. No trend would be horizontal, right? But trend and seasonal, if they're combined, this would be a good example here. So this is smart sales phone. So if I just draw the line chart, getting rid of the grid lines. I'm not going to add the axis title, but yeah, so we have sales, and this one is quarter. All right, okay. First step, add trend line. So we have a positive slope, significantly positive slope, so that indicates the existence of trend. Now, are the fluctuations around this straight line completely random? If they're random, then that would be a trend. If they're not 100% random, if they're repeating themselves, then that would be a combination of trend and seasonal. So let's see. Again, we have quarterly sales information. So I'm going to take year 1, year 2, year 3, and year 4. So every year we see that the pattern is pretty similar to each other. So the pattern would be like this: down, up, up, down, up, up, down, up, up, down, up, up. So the minimum happens in the second quarter every year, and the maximum happens at the last quarter. And the same pattern repeat itself. All right. So we have seasonality and we have trends. So when you have both seasonality and trend in your data set, then that would be a case when you have seasonal and trend. So the technique that we use for this one is slightly different from the trend and from the seasonal. So that basically combines the techniques that we use for trend and seasonal, right? So the last time series pattern would be cyclical. So cyclical time series are defined as patterns when you see sinusoidal movements around either a flat line, around a horizontal line, or around a straight line, which I'm going to call it a trend line. So sinusoidal movement, alternating movements around a straight line. And so the difference here with the seasonal, the main difference would be that cycles are usually significantly greater than a year. And so that's one difference. The second difference would be that usually the lengths of cycles change. So we have a changing length of cycles. Lengths of cycles may change. So this is another difference with the seasonal pattern. So cyclical pattern. House price is something that most people believe that it has cycles. And so here we have an imaginary example for ABC County. And if I just draw this time series using the line chart, we'll see that there are some sinusoidal movement, as you can see here. So I'm just gonna get rid of the grid lines. So this is the house price. So price, and then this would be year. All right. So as you can see here, it goes up, and at some point it starts declining, and again goes up, goes down, goes up, and a lot of people now are waiting for it to just maybe go down for a few years maybe, and then go up again. So this is really, and I mean, you can add the trend line and you'll see how this is actually fluctuating. So if we draw the trend line, remember again, so here we have a full cycle. We have a full cycle from here to here. So that's one cycle. The second cycle going up, down, down, and again going back here. So here is the second cycle from here to here. One sinusoidal, complete sinusoidal movement up and down and back up to the point that it should be if it wanted to follow the trend line. All right, and then it's going up again, and maybe this year, maybe next year, maybe in a few years, it's due for another decrease. All right, so this is a cyclical pattern. Cyclical patterns are much more complicated than the other time series pattern. When we're dealing with cyclical patterns, usually fundamental analysis and causal forecasting usually work better when we are dealing with cyclical pattern.